Hello, welcome to this video. We are talking about functions in Python, and specifically the topic today is submitting the opinion that it is better to make bite-sized logic than it is to make these really big functions that do a lot of things, perhaps too many things all at once. Just to nail down some things from the beginning here, one of the benefits you're going to get from pushing your logic into these smaller bite-sized functions is you're essentially building a toolbox. You have a hammer, you have a screwdriver, you have these different tools that solve different jobs, and you might have things that you need to do tomorrow that can use pieces of what you built today, what you built yesterday. And this is one of these big benefits of starting to move into this mentality of don't just build a function that gets the specific job or this macro job done where maybe you have many parameters defined for how this function is going to behave. Maybe instead you can build smaller, more bite-sized functions that do more specific tasks that are going to be interchangeable in any given workflow. So that's the big benefit here. It's not to say that the function that we're going to be looking at is absolutely terrible and that you would never want something like this. It's more about how do you become a better developer where the work you do on any given day is work that you won't have to do again. You won't have to reinvent as many wheels down the road. So in this case, we make a function that's, this is fine. I've seen worse things in production than this. I've written worse things than this. But this is going to help us illustrate our point. So we have a function called getProcessData_df. df, of course, stands for data frame in the pandas world. Pandas is the package that you're going to be using a lot if you're working with data in Python. So we define a file path, that's where the data lives. We define state filter, I wonder what that is. Minimum quantity, interesting. Columns, and row limit. Now I'm giving the dramatic rendition here, but some of these parameters defined for the function, these are going to be arguments that the person using the function needs to provide to the function for it to do various things. These are not necessarily obvious what they're doing because our function is doing quite a few things. It's doing multiple things. It is not just doing one thing and doing that well. This function is, maybe arguably doing one thing. It's getting processed data, but that one thing actually forks off into multiple things. Those things include reading the data in, defining additional new columns or features for this data frame, and then also applying a couple filters. Then finally, it's going to apply another kind of filter. This is pruning the columns, which will be returned. So if the user only wants, 4 of the 12 columns, they'll only get those 4 as output. And then it's going to do a row limit, which, in this function, it's not really obvious if this is the first n rows or the last n rows, or is it only reading in this much data? Who knows? Not the user of your function, because you don't have a doc string explaining what's happening, and your function name isn't explicitly, it's not making it clear exactly what this function does. So not the worst function that I've ever seen, but there are better ways in my opinion. So this function's doing multiple things, just to get the cliff notes here, the summary. Function is doing multiple things. This could work, this could be fine, but there's probably a better way to do this stuff. Here we can see how the function is going to actually be working in practice. And we can see that indeed when we pass in a state filter, that appears to be filtering this column called state to only the state that we pass in. Just as a demonstration of how these things work. So we can see in here that these other filters, they're optional, available to the person if they want to use it. All right, so that function works, and just have a little bit of, want to get on my soapbox here and preach the good word that this works. That function that we made up there, it really does work. It gets the job done. This is fine for some people. I'm not trying to say that you can't write functions that do more than one thing. I'm saying in general, you're probably going to get more net benefit if you do as much as possible. You try to take the logic that might be doing multiple things from one function, just try to split that up and say, is there something in here that I could just push out to a smaller function, and then it's going to be more generalizable? Like, instead of just solving that problem in this very niche way for this bigger function, maybe I could solve this problem in a more general way that's going to be useful to me in many, many more applications. So that's just my argument here. So we could take that same function that we built above and we could say, okay, well, maybe we want to get our superstore data. Maybe you have 100 different use cases where you'd want to use this data. Maybe you even go further and you just say, you write a function that retrieves data from a particular system and it doesn't even care what data that is. All you have to do is tell it, the specific location of where that data is, and then you're going to get that data back. In this case, we're just using this pd.readCSV. So do you really need a function for this? I don't know. But in this case, in this dramatic rendition, we do. So then we have apply derived columns. This function is only going to do one thing. That thing is to take a data frame that we have and calculate new features for that data frame. We calculate something called profit ratio. We calculate something called the discount value, which takes whatever the discount percentage was, multiplies that by the sales, and that's the actual amount that was discounted. These are crucial ingredients for our fake analysis of this fake data. Then we have apply filters. So filters are just going to be various things that we want to do, which are going to limit the row set that's returned to us. Maybe we want to only get rows that meet a certain quantity threshold, that have a certain value for state, etc. So we apply our filters. We get our data, we do the derived columns, we apply our filters, and this is achieving the same thing our one big function had. But the real benefit here is not that you had to write fewer lines of code. In fact, you might end up writing more lines of code, but the benefit is that you have solved what were all these smaller problems that were mashed together into one function. You now have the benefit of having these smaller functions that you could fit into any given workflow. Maybe we only need 2 of these 3 pieces. Maybe we only need 1 of these pieces, but we already wrote that code, so we don't have to write it again in the future. Okay, so here's just an example of, now that we have that code, we could completely replace the function we had before by stitching together our pieces. We get the superstore data frame, we transform this data frame using our function where we apply derived columns, and then we pipe this through to another process where we're going to be applying filters. This is a kind of beneficial mindset to have, where maybe you have a pipeline, and at a really high level you can look at the code and say, okay, we get the data, we transform the data by applying some derived columns, and then we apply some filters to that data. And then the high level function that's operating here, maybe we have to add another high level step at some point in the future, and then we can go out, we can build the nitty gritty code that does that, put it behind another high level function, and then we can keep the layers of logic a little bit more organized and clean. Rather than throwing all of the books just randomly onto shelves in the library, you have things organized into something that you can, if there's a change that needs to happen, you get a new book, you want to insert it to a shelf, there's a specific place to do that. Very similar here with our functions. We can see this function's behaving in the same way. We can still filter on Kentucky. And then you have this benefit of being able to approach things in a more kind of functional, modular way, where you could mix and match your functions on the fly. And as you build your toolbox of functions, of logic that you can use, you're going to be much better equipped to solve whatever problem comes at you tomorrow, because you've solved so many problems in a generalizable way, yesterday, that who knows, maybe you encounter a problem, you don't even really need to write new code because you've written such good code previously that it fixes that general kind of problem. Okay, so that is all I wanted to talk about today. I hope this helps somebody out there. And if you're still writing these big, chunky functions, that's fine. Just start thinking about, is there a way for you to break that up into smaller pieces that will be useful to you in other contexts as well? Not about who's right or who's wrong. It is just about finding that thing that makes you get the stuff you're trying to do done as effectively as you can. So hope this helps somebody, and see you again soon.